Sorry, my phone rang and then the video stops going. I should really turn off the... Okay, so where I was right here is once you get to this subtraction law, which is really a quotient law, when you see that, you know you have to set up the quotient of 108 and 2. So 108 divided by 2, I got to be 54. And then the last line was really that once I have two equivalent base 3 logarithmic functions, then this number here has to be the same. So if it's 54 on the right, then this x must be 54 as well. So you can see from all of this, you get a very streamlined solution where you're using the 3 logarithm laws that we know so far, okay, to get x equals 54. Okay, the second example, equally as nice. Sorry, this video is going to be in 2 parts. Okay, so what color did I just use? I'll do this one. So in this one is example B here. Log x base 5 minus. Okay. So a couple things to do, and we're going to follow the exact same rules I used last time. We want this, where the x is, to be all by itself on this side of the equation, okay? Which means we want to bring this over. So when I bring a negative over, it becomes positive. Fine, I'll put it right here. Okay, bring it over, and then I'm going to write the rest of these. Log base 5, 6. Now, because I want to work a little quicker, I'm going to look at the fact that there's a 3 being multiplied out front here and say, I can't use any of these laws if there's a number out front. But I use this law backwards. I see the 3 out front. I'm going to put it back up here as an exponent on the 2. Okay, so really what I have sorted out here is 2 additions. Okay, well, 2 additions is not going to be difficult. I'm going to do the first one here. I can rewrite that as a single base 5 log. What do I do with the 8 and the 6? I multiply them. That's how the addition formula works. We're going to multiply. And then over here, I'm just going to actually do this calculation. 2 cubed is 8, so I'm just going to write it in there like that. So here I now have log base 5, 6 times 8 is 48. I put that in there. And then the very last step is just to say, well, I again have an addition. Both of them base 5. What do I do with the m and the n value? I multiply them. So then, I feel like my posture is getting worse out here. 48 times 8, 50 times 8, 400 minus 16, 384. Okay, and again, once I have 2 logarithmic functions, base 5, this x value must be equivalent to what's over there. Okay, so it's just a matter of applying the logarithm laws. It's not overly difficult at all. It's kind of like a fun little puzzle to solve. If you could solve exponent law questions, I'm sure you can solve logarithm law questions. Okay, perfect.